Hey there, this is Mathcamp321, and this is another installment of a video series on logarithms. This particular video is part 6 and discusses basic solving techniques. Each equation below involves logs in some way. The techniques used to solve these equations are quite different. Be sure to compare and contrast the different solving techniques as you work through each problem. Directions: solve each equation. Before we get started, there is an additional rule that I need to just tell you, and we're going to explore the reasoning behind that rule a little bit later when we discuss graphing. The rule is that the argument in a log equation must be positive. So that's just something to keep in mind as we start the solving process. So number 1 says log x base 3 is equal to 2, and our objective is to solve for x. What I think I'm going to do in this problem is start by doing a simple swing. So I'm going to start with that little base of 3. I'm going to swing up to the right, and I'm going to land at x. This will allow me to rewrite the log equation as an exponential equation, and it would be 3 squared equals x. Well, 3 squared is of course 9, so the answer is just going to be 9. So that first problem started off really easy. Let's move to number 2. Log 5 base x is equal to 3. Again, I'm going to start with a swing, starting with this little base of x, swinging up to the right towards the 3, and landing on the 5. This will yield the corresponding exponential equation x cubed equals 5, or x to the power of 3 equals 5. To solve something like this, I'm going to take the cube root of each side. So we've isolated x, and we've gotten a final answer of the cube root of 5. Again, this wasn't too difficult. Moving to number 3. 3 to the x is equal to 2. Well, earlier in our course, not in these lessons, but earlier in our course, we learned how to solve an exponential equation using something called the common base method. And we were able to do that if the two bases on either side of the equation were able to be rewritten with some common base. In this problem, though, we have a base of 3 and a base of 2, so it's not going to be possible to do that. So what I'm going to do is I'm going to take the log of both sides, and this is something that I did in an earlier video in the log series. Step 1 will be to take the log of each side. This leaves us with log of 3 to the x equals the log of 2. On the left-hand side, I can implement the Power Ranger rule, and that exponent of x can jump down in front. So my next equation will be x log 3 is equal to log 2. To get x completely isolated, I'm going to divide both sides by log 3. They're going to cancel on the left side, and I'm going to be left with a final answer of x equals log 2 over log 3. There is an opportunity for further simplifying, and that is to use the change of base formula backward. Remember, in the change of base formula, the base goes in the basement. Well, the base is already in the basement, so I can go back and write this as the log of 2 base 3. Either one of these forms would be acceptable, and perhaps if you saw this on a standardized test, which is multiple choice, you might have to select from between these two options. Let's go to the next slide where the problems will increase in difficulty. In question number 4, we're asked to solve the equation 2 log x plus 4 base 3 is equal to 6. It's tempting in this problem to start off by swinging, except for the fact that there is this 2 in front, which sort of complicates things. Before I can swing, I need to isolate the log expression. So I'm going to need to start off by dividing both sides by 2 to get that log expression isolated. Now that the left side has been completely isolated, I can do the swing that I wanted to do before. Starting with the little base of 3, swinging up to the right, and landing on the expression x plus 4. This leaves me with an equivalent exponential form of 3 to the power of 3 is equal to x plus 4. 3 to the power of 3 is of course 27, so my new equation becomes 27 equals x plus 4. Subtracting 4 from both sides, I end up with a final answer of x equals 23. So it's important to remember for questions like this that you cannot swing unless the log expression is completely isolated. And something like that 2, which is in front, needs to be divided out before you can actually do the swing. Let's go to number 5. In number 5, the question is 5 to the power of x plus 1 equals 6. Now, if it were possible to get common bases with both a 5 and a 6, this would be a pretty easy question, except that it's not possible to do that. So my strategy here will be to take the log of both sides. In doing that, I'll end up with the log of 5 to the power of x plus 1 equals the log of 6. In the next step, I'll do the power rule, or the Power Ranger rule, which will allow the exponent, or the power of x plus 1, to leap down in front of the log expression. Because the x plus 1 is a multi-termed expression, parentheses are going to be absolutely critical. Now the log of 5 is just a constant, so instead of writing it on the right side of the parentheses, I'm just going to write it on the left side of the parentheses, and I think that'll make more sense in a moment why I do that. Let's remember that the log of 5 is just a constant, and when there's a constant on the outside of a polynomial, I can distribute it on through. So I'm going to go ahead and do that by multiplying it to x and also multiplying it to 1. In doing that, I'm going to end up with x log 5 plus log 5 equals log 6. Now I'm going to start the isolation process. I'm going to subtract the log of 5 from both sides. And to get x completely isolated, I'll now divide both sides by log 5. Now, in problems like this, I'm always looking for opportunities to simplify. And I notice that in the numerator we have a difference of logs. If you use your properties of logs backwards, a difference of logs turns into the log of a quotient, or the log of 6/5. And there's actually one additional thing I can do if I'm really being picky. At this point, we have the ratio of logs, and when you have the ratio of logs, this is just like the change of base formula, but in reverse. We have a situation in which the base is in the basement. So as one final step, one final option, we could write this as the log of 6/5 base 5. So I've now expressed the final answer to this question in 3 different ways. Hopefully you'd see something like this on a standardized test which is multiple choice, and you'd be able to kind of scan through and figure out what they wanted. It's always tough on a regular quiz that's open-ended to know where does the teacher expect me to stop. So just from this video, I just want you to be aware that there are 3 different forms for the answer here, and just be comfortable with all 3 of them, and then just hope that you'll see this on a multiple choice where you can just select it from options. Let's move on to the next slide.